The name of experiment is Pitot tube. First of all, let's see what is the aim of our experiment. The aim of the experiment in Pitot tube is to study and measure the velocity of the flow using Pitot tube. So by using this device, we can measure the velocity and the flow rate of the fluid by using the Pitot tube. Basically, we have already studied that Pitot tube is a flow meter, and it is a which type of flow meter? It is a variable height type flow meter. See, this is the basic figure of Pitot tube. See, this shape, the tube is Pitot tube. So when the flow comes from this side with a particular velocity, then here at this point there is a change in pressure, and in this tube the pressure measured is known as stagnation pressure, and here the pressure measured is known as the static pressure. Right? Now let's see some theory about Pitot tube. Basically, a Pitot tube is a pressure measurement instrument used to measure the fluid flow velocity. So that means based on the change in pressure, we can measure the velocity, and from velocity we can measure the flow rate of a fluid. Right? The basic Pitot tube consists of a tube pointing directly into the fluid flow. We have already seen the figure. The Pitot tube is a tube pointing directly into the fluid flow. That means we insert the tube inside the fluid flow direction. As this tube contains fluid, a pressure can be measured and the moving fluid is brought to rest. Rest, that means static, as there is no outlet to allow the flow to continue. As we have inserted the tube inside the flow, at that point the moved fluid is stopped. So that means it brought into the rest. So it is not allowed to flow further. This pressure is the stagnation pressure of the fluid. That means at that pressure, we call that pressure as stagnation pressure. And also as the total pressure or the Pitot pressure. That stagnation pressure is also known as the total pressure and Pitot pressure or Pitot pressure. Right? And the measured stagnation pressure cannot itself be used to determine the fluid velocity. This point is very important. That measured stagnation pressure we cannot use directly to determine the flow velocity. Then how we can determine the flow velocity? Let's see that. However, Bernoulli's equation states that stagnation pressure is static pressure plus dynamic pressure. We have already studied Bernoulli's equation. So from that Bernoulli's equation, it states that stagnation pressure is static pressure plus dynamic pressure. Right? So I can write that mathematically as total pressure or stagnation pressure is equal to static pressure plus dynamic pressure. What is dynamic pressure? Dynamic pressure is V square by 2G, and this is static pressure PS, and PT is stagnation pressure or total pressure. So when I solve this equation for V or for velocity, that will give you the form as V is equal to under root 2G into bracket PT minus PS. Right? When we will solve this equation in terms of velocity V is equal to under root 2G into bracket PT minus PS, where V is the fluid velocity, PT is total or stagnation pressure, and PS is the static pressure. So by using this formula for Pitot tube, we can calculate the velocity of the fluid, and from that velocity we can calculate the fluid flow rate. Right? So by the use of total pressure and static pressure, we can calculate velocity, and from that we can calculate the flow rate. Let's see our experimental setup, how it looks like. Basically, the setup consists of a simple clear perpex channel with two tubes. Here, see this part. In this part, we have inserted a Pitot tube here. We will see in our video of experiment with two tubes each to measure static and stagnation pressure of the fluid in the channel. So, the liquid which flows from this channel and with the help of these two tubes, first tube measures static pressure and this Pitot tube measures the stagnation pressure or total pressure. The channel is supplied water with the help of tank and the flow is controlled by a gate valve. You can see here in this setup. The water flowing from this tank through this channel. In that we have inserted the Pitot tube. Right? And with the help of valve, here you can see, with the help of valve we can control the flow rate of the fluid. And the scale is imparted next to the tube to measure the pressure heads. Here, see here. This is a scale which is installed here to measure the pressure head. Right? So this is the brief of our experimental setup. Right? Let's see the working procedure of our experiment, Pitot tube. First of all, we have to switch on the pump and fill the tank that supplies water to the Pitot apparatus. Then now slowly open the Pitot outlet valve so that channel is filled completely with the water. In the second step, we have to slowly open the Pitot outlet valve so that our channel in which the Pitot tube is installed is filled completely with water. Now we have to observe and note down the pressure head reading in the meter of water. So at this flow rate, our first step is to note down the reading of pressure head. And from that calculate the time for discharge for a known quantity of water. So for a known quantity of water, we have to note down the time required for the discharge. Right? And in the last step, with the help of the pressure head reading and with the help of the discharge of the water, we can calculate and compare theoretical and actual velocities. Right? So these is the steps for the experimental procedure. Right? See, now let's see the working video of experiment. See here. This is the setup of our experiment. This is storage tank where water is already filled, and when we start this pump, the water circulates from this to Pitot apparatus, and this is the pipe. See here. From this pipe, the water is flowing and collected in this measuring tank. Right? Now here you can see this is the Pitot tube. See. See. This is the Pitot tube and this is the static tube. See here the shape of the Pitot tube which is inserted in this channel. See. It is like this. You can see clearly. The Pitot tube is like this. So here we can measure the stagnation pressure head. See. And from the static tube we can measure the static pressure. See. So when water comes from this channel, from here we can take reading of static pressure and from here we can take the reading of stagnation pressure. This is our first reading, and in second reading we can measure the discharge of water in the measuring tank with the help of this scale. Right? See, this is working video of our experiment. Now from the reading of static pressure and stagnation pressure and the water flow rate, let's do the calculation. The size of the flow channel is given 0.02 meter And observation table. In observation table, we have note down the readings. See, this is PT, that is the total pressure. With pressure head, be specific. This is PT is total pressure head, which we have taken reading from the Pitot tube. That is here. PS is the static pressure that we have taken the reading from the static tube. This is PT minus PS, the difference of that two. V Pitot, this we have to calculate. I'll show you. This is the time required to collect the water. This is volumetric flow rate and this is velocity measured. Let's see how we can calculate these values. I have shown you here the reading or the calculation for the first reading. Area of channel is pi by 4 d square, size is given 0.02 meter. So area of the flow channel will be pi by 4 0.02 square, which is 3.14 into 10 raised to minus 4 meter square. PT minus PS for the first reading will be 0.11 minus 0.107 is equal to 0.003 meter. Now in next step we have to calculate the volumetric flow rate Q. Volumetric flow rate Q is AR by T. A is the area of flow channel, R is the height which we have noted for the particular time period. That is 3.14 into 10 raised to minus 4 into 0.10 divided by 10. When you solve this, you will get the answer of volumetric flow rate Q will be 3.14 into 10 raised to minus 6 meter cube per second. So now I can calculate V measured, that is measured velocity, because I have the value of Q and I have the value of area. So measured velocity V is what? Volumetric flow rate divided by area, you will get the V measured equal to 0.01 meter per second. And now we have to calculate the Pitot velocity, that is V Pitot. We have already seen the formula for this. V Pitot is equal to under root 2G PT minus PS. When you solve these putting value, then you will get the answer of V Pitot as 0.2426 meter per second. Fine. So this way we can calculate the both velocities. Right. Now I have to calculate the coefficient of discharge. We know that coefficient of discharge is the ratio of measured velocity to Pitot velocity. So it will give you the answer of coefficient of discharge as 0.041. Fine. So by this way we can calculate the values for the second reading also. Now let's see which are the application of Pitot tube. First, Pitot tubes are used in the anemometers to measure the air speed in wind tunnels. The main application of the Pitot tube is to measure air speed in the wind tunnels. It is also used where very high accuracy is not required and used to measure the flow profile in duct or channel. So these are some of the application of the Pitot tube. So what is the conclusion of our experiment? The experiment of Pitot tube can be used for the measurement of velocity of the fluid, and from that fluid velocity we can calculate the flow rate of the fluid. Fine. So I am completing this session here. I hope the experiment Pitot tube is clear to all. Thank you.